Now let's balance it. I have 1 aluminum on this side and 2 on this side. I can fix that by putting a 2 in front of this. Now I have 2 aluminums on each side. If I look at the iron here, I notice that I have 2 irons and only 1 here. So I'm going to fix that by putting a 2 in front here. Lastly, I balance the oxygens, 3 oxygens and 3 oxygens, and this equation is balanced. Let's look at number 6. In number 6, Pb is lead. Lead 2 chloride reacts with lithium sulfate to produce lead sulfate plus lithium chloride. It appears, since this has a positive and a negative part, this has a positive and a negative part, that the positive parts, the lead and the lithium, have switched places. When they switch places in the products, we call that a double displacement reaction. Now let's balance it. I have 1 lead on this side of the equation and 1 lead on this side of the equation. That's good. I see that there are 2 chlorines on the left-hand side, but there's only 1 chlorine on the right-hand side. So in order for this to balance, I have to double the number of lithium chlorides that I have. That works out well because when I come back to the left-hand side, I see that there are 2 lithiums, and now I have 2 lithiums here. Like in the question number 2, I see that the polyatomic ion sulfate does not decompose or break down. It stays the same on both sides, which means I can balance it as a whole. I see that there is 1 sulfate and 1 sulfate here, so this equation is now balanced. In number 7, I have chlorine gas, notice that it's diatomic, and potassium bromide combine to make bromine, also diatomic, and potassium chloride. I have a free element here mixing with a compound to produce a different free element and a different compound. Clearly the chlorine has come in and taken the place of the bromine in this compound. Since one is pushing out another, this is single displacement. Now we balance it. I have 2 chlorines on this side, but only 1 on this side. I can fix that by doubling what I have in the product. Now 2 times the 1 chlorine is 2 on both sides. When I come to this side, I have 1 potassium, K, but because of my addition of the coefficient here, I have 2 on this side. I can fix that by putting a 2 here. Lastly, bromine. 2 times the 1 bromine yields 2 bromines, and over here I have 2. So this equation is now balanced. Number 8, I have phosphorus pentachloride yields phosphorus trichloride and chlorine gas. Since I'm starting with a single compound and ending up with 2 compounds, or 2 substances, the first one is a compound, the second one is a free element. Because I've gone from 1 to more than 1, this must be a decomposition. Now we balance it. I have 1 phosphorus on this side and 1 phosphorus on this side. So far so good. 5 chlorines on this side, and chlorine is present in 2 places here. I have 3 here and 2 here. If I add them together, that's 5. This equation is already balanced. In number 9, I have sodium, that's the free metal, and chlorine, which is a diatomic element, react to form sodium chloride, which is just common table salt. Because I have 2 substances combining to form 1, That must be a synthesis reaction. We're synthesizing table salt. Let's balance it. I have 1 sodium here and 1 sodium here. On the left hand side I have 2 chlorines, but only 1 chlorine on the right hand side. I can fix that by putting a coefficient here. Now this gives me 2 sodiums on this side, so I have to go back over here and correct that, and the equation is now balanced. The last equation, I have C6H12O6. You'll remember this from biology. This is the molecular formula for glucose, which is a sugar, combining with oxygen to yield carbon dioxide and water. If we start with the carbon, we see that we have, well, let's back up and look at the reaction type. Anytime we have a hydrocarbon or a combination of carbons, hydrogens, and oxygens, and it combines with oxygen, free oxygen, with products being carbon dioxide and water, that's a combustion reaction. In biology, you would call this respiration. We have 6 carbons on the left-hand side, but only 1 here in the form of carbon dioxide. We can fix that by putting a 6 in here. Now we have 6 carbons on each side. Hydrogens, there are 12 hydrogens, and there are only 2 in water. In order to have 12 hydrogens in the water here, I can put a 6 in front of this, because 6 times 2 is 12. Now we have 12 hydrogens on each side. Lastly, I'm going to balance oxygen, but with combustion reactions, again, I'm going to balance it backwards. And I'm also going to do it last, or should always do it last. Let's take account of the total number of oxygens. 6 times 1 in the water is 6. 6 times 2 in the carbon dioxide is 12. So 12 plus 6 is 18 on the right-hand side in the products. Oxygen appears twice in the reactants. So the first thing that I'm going to do is subtract the ones that are not coming from the free oxygen gas. So I have 18 total that I need to account for, and I'm going to subtract the 6 that are here in the glucose. And that leaves me with 12 oxygens that I need to account for. The 12 oxygens come from the oxygen gas. So how many pairs of oxygen does it take to make a total of 12 oxygens? Well, it takes 6 pairs. So we have 1 glucose plus 6 oxygen yields 6 carbon dioxide plus 6 water molecules. I hope everybody did well on this assignment.